Suppose the sum of the three angles of a triangle ABC equals pi radian. We need to show that the sum of cosine of 2 and cosine of 2b minus cosine of 2c that equals to 1 minus 4 times the product of sine A, sine B and sine C. Okay, let us begin with a proof. Now this particular question involves conditional trig identities. Now what are conditional trig identities? We can understand this with the help of an identity. Sine squared theta added to cosine squared theta equals to 1. Now this is an identity because it's true for any values of theta that we choose. For any values of theta, this is always going to be true. However, for our particular problem, this is only going to be true for some specific values of A, B and C. That means the values of A, B and C, these three angles must be such that their sum must always equals to pi radians. Only then we can say that this identity is going to hold true. So such identities are referred to as conditional trig identities. Now for our purpose, we're going to start from our left hand side. So from the left hand side, so here we have cosine of 2a added to cosine of 2b minus cosine of 2c. Fine. So we need to first add the two cosine function, the first two terms, cosine of 2a plus cosine of 2b. So here we're going to use the formula that whenever we have cosine of c added to cosine of angle D, that's simply given by 2 times cosine of the angle C plus D over 2 multiplied to cosine of the angle C minus D over 2. Okay, so this is going to be equals to 2 times cosine of the angle A plus B multiplied to cosine of the angle A minus B minus, so here we have cosine of 2C. Now there's a standard formula for cosine of 2 theta. The cosine of 2 theta can be expressed as cosine squared theta minus sine squared theta. Now if we make use of this identity, then we get two more forms of cosine 2 theta. So that's going to be 2 times cosine squared theta minus 1, and the other one is going to be 1 minus 2 times sine squared theta. Now from these three forms, we're going to take one form. Now we are going to take one form such that we get a positive one, because we need positive one on the right hand side. Now we have negative cosine of 2c. Now what form of cosine 2c that we should take from these three forms? So we will be taking 2 times cosine squared theta minus 1, this particular form. That means for our case, cosine of 2c, that's going to become 2 times negative 2 times cosine squared c plus 1. Okay, fine. Now what we'll do, we're going to manipulate a plus b here. So that means in place of a plus b, can we not write pi minus c, and it would mean exactly the same thing? No, this is going to get multiplied with cosine of a minus b minus 2 times cosine squared c added to 1. Okay, now what is cosine of pi minus c? We have a standard formula, cosine of pi minus some angle theta that corresponds to negative cosine theta, and it is going to be negative because we are in the second quadrant of pi minus theta. That's always in the second quadrant. Okay, so that means we now have negative 2 times cosine of angle C multiplied to cosine of the angle A minus B minus 2 times cosine squared C added to 1. Now let's do one thing. Let's write the third term as the first term, so we get positive 1. Now from the first and the second term, if we take negative 2 times cosine C as the common factor, that means it is going to get multiplied to cosine of A minus B added to cosine of angle C. Fine. Okay. Now what is cosine of C? So we'll come to that. We have 1 minus 2 times cosine of angle C. This is going to get multiplied to cosine of the angle A minus B. Now let's understand cosine of C. Cosine of the angle C, this can be also expressed as cosine of pi minus A plus B. Okay, so we can express cosine of C as cosine of pi minus A plus B. Now if we use this particular formula, then cosine of pi minus some angle theta, that's going to be negative cosine of the angle theta. That means we have negative cosine of A plus B. In other words, we can replace this cosine C with negative cosine of the angle A plus B. Now the reason why we made this transformation, because now we have difference of two cosine function. Now there's a standard formula, whenever we have cosine of C minus cosine of angle D, so this is going to be given by 2 times sine of angle D plus C over 2 multiplied to sine of angle D minus C over 2. For our case, here we have C corresponding to A minus B and D corresponding to A plus B. So let's write it down so that we do not mistake for anything else. So A minus B, so we're going to consider it to be equivalent to C, and A plus B we're going to consider it to be equivalent to D. Okay, fine. This is only for our understanding purpose. So we have now 1 minus 2 times cosine of angle C. So this is going to get multiplied to 2 times. So we need D plus C. That means D plus C, that means we have A plus B added to A minus B. So that's going to give us 2A, and dividing by 2 gives us A. Multiplied to sine of, now we need D minus C. So A plus B, if we take A plus B and from it we subtract A minus B, so that's going to give us 2B. And since we have division by 2, so we're simply going to get B. Now this is the final result. So there's a mistake, there's a typo in the problem. So this is actually not sine C, but it is actually cosine of C, which is the expression on the right hand side. So here, what we have done is we started out by considering cosine of 2A added to cosine of 2B minus cosine of 2C, and we obtained this as 1 minus 2 times sine of angle A times sine of angle B multiplied to cosine of angle C whenever we have A plus B plus C equals to pi radians, hence proved.